pouring vinegar onto baking soda powder to make a stinky, bubbly, messy volcano is a science fair classic. Today I will be performing that chemical reaction and teaching about a nice basic chemical equation. Then I'll throw in a pretty cool bonus. Baking soda right here. A single molecule of baking soda is made of a sodium atom and a hydrogen atom and a carbon atom and then 3 oxygen atoms. That's why it is called sodium, hydrogen, and then carbonate. Carbonate is the term for a carbon atom and 3 oxygen atoms. It's a special thing called an ion, and if you want to know what an ion is, you need to talk to an 8th grade science teacher. We'll put it together with vinegar. Vinegar, we just call it acetic acid, and it's 1 part hydrogen, 2 parts carbon atoms, 3 more hydrogen atoms, and 2 oxygen atoms. Now, if you're curious why these guys are like that, instead of just H4 to show a total of 4 hydrogen atoms, I can show you this is a model of a vinegar molecule, and as you can see, this hydrogen atom is bonded only with one of the carbon atoms, and these 3 hydrogen atoms are bonded with one of the oxygen atom. The formula here is just showing what it really looks like. Well, they come together, and then in math there'd be an equal sign, but in chemical equation there's a big arrow, and the big arrow we say yields, and that can mean it makes, it results in. Let's take a look at what happens at this point. First thing that's being made is called sodium acetate. It is one of the sodium atoms. It's 2 carbon atoms, 3 hydrogen atoms, and then 2 oxygen atoms. Now, you'll notice that the acetic and acetate, that just means this one was neutral and this now has a negative electrical charge, but again, that's going a bit beyond 6th grade. If you leave this alone for long enough, the water boils out of it and it starts heating up. It crystallizes and heats itself up. It's actually warm to the touch. It becomes super saturated, basically concentrated. Now, we've got right here what happens on the way down. It tries to form a combination of water and carbon dioxide. That's actually called carbonic acid. This is the formula for that. But we can get rid of that because carbonic acid, it's unstable. It just can't exist. So in a fraction of a second, it undergoes a decomposition reaction. It breaks down. It breaks apart into the H2O and the CO2, water, and carbon dioxide. Now, before we go on, and well, actually do it, I want to talk about conservation of matter. Conservation means keeping something. Even when things change incredibly, come together and change, and it looks like it's just not there anymore, the atoms are there. They can't just disappear. And so we're going to be seeing they all match up. All the letters and numbers that you see here, there were 3 plus 2, there were 5 oxygen atoms coming together. Well, 1, 2, 3, 4, 5. Hydrogen, 1, 2, 3, 4, 5. Down here, after the reaction, 1, 2, 3, 4, 5. I could do that with all of them. Conservation of matter. The atoms are not just gone. There might be in different combinations. They sure might look different, but they are in there. Well, let me tell you what's going to happen when I put them together. The reaction is going to cause carbon dioxide bubbles to form. The bubbles you see, if you've ever seen this before, it's not just more air. It's pure carbon dioxide. One carbon atom plus two oxygen atoms put together, it makes a gas. It's the same gas that you breathe out. It's the same gas that plants breathe in. And it has an interesting property, and that is that it is, well, you could say it's heavier than air. More proper to say that it's more dense than the mostly nitrogen plus oxygen and some other stuff mixture of our air. It's did I say less dense? It's more dense. It's not going to just drift on up here. When the bubbles form, the bubbles will immediately start popping, and the gas will just stay down there in the container. It would be like if you had a bunch of water balloons that you started popping in a trash can. The water is going to stay down there in the trash can. Well, this is why fire extinguishers shoot carbon dioxide. There's nothing really exactly special against fire with carbon dioxide. It's just that it sits on top of the fire like someone throwing a big heavy blanket over the fire, and that robs the fire of the oxygen it needs. It's still going to have its heat, it's still going to have its fuel, but when the oxygen gets removed, the fire goes out. And so, I did a little bit of research. I found out that a 12-to-1 ratio, 12 parts vinegar to 1 part baking soda apparently is the best. I'm going to be pouring both of those into this bigger one, and we'll see a big foaming up of bubbles, but we'll also see this. If you're going to do this at home, of course, get parent permission because it involves fire, but also be sure you're using one of these candles that comes in a jar. That will give the carbon dioxide gas place to settle into. It's gonna be as if you're seeing me pour invisible water. I'm gonna be pouring like this, and you're not gonna see anything happening. Carbon dioxide is colorless, but the candle should just go right on out. You can do a bit of a close-up expert camera technician there, camera operator. Vinegar into baking soda, chemical equation, sodium acetate, plus water, plus carbon dioxide is what's going to be produced. Here we go. Bubbles popping, filling up with carbon dioxide in there. You can't see it, but it's there, and I'll prove it. Out like that. In closing, I will just say I hope that helped teach you some of the basics of chemical reactions, especially the chemical equation where you can see on paper what is happening. And I will also tell you that when my daughter saw this written up, she was thinking I was coming up with a new recipe for nachos. I was sorry to disappoint her, but I hope you enjoyed that.